These are today's notes for pre-calc on graphing just the parent graphs for sine and cosine. Now we're going to start with sine, and we're going to start both graphs kind of the same way with your unit using the unit circle. Now you already know that when you're looking at the unit circle, the sine is the second, or the sine is the y value in every point. So pi over 4, of course, that's radical 2 over 2. Now this is going to be hard to graph, so we're going to use the decimal just for graphing. The answer is radical 2 over 2. The decimal is not the exact answer, it's rounded, but just so we have a place to put it on the graph. At pi over 2, the sign is 1. In the second quadrant, this is positive radical 2 over 2. When we get to pi, the sign is 0. Down here, in the third quadrant, the sign is negative radical 2 over 2. Straight down, the sign is negative 1. At 7 pi over 4, it's negative radical 2 over 2. And at 2 pi, it's at 0. Now, what is missing is what I would consider to be the first point, right? This one right here. So at 0, the sign is 0. And that's going to help us draw the graph. So we're going to plot these points on the graph. And then we're going to try to study the pattern of some of these answers so that we can come up with the answers to the below. On the embedded assessment, you're going to have to study the pattern of the graph that you draw and answer some questions. So this is a skill that you'll have to do again. So the sine of 0 is 0. At pi over 4, it's radical 2 over 2, which is not quite 1. At pi over 2, it's 1. At 3 pi over 4, it's radical 2 over 2. Pi is 0. Then we get to negative radical 2 over 2. Negative 1. Negative radical 2 over 2. And back to 0. So you can see having these points equally spaced and graphed correctly, you get a very nice curve. Some patterns to this curve is that it's not pointy. Do not draw it with points. It also, if we study this for one cycle, which would be one rotation of the circle, or 2 pi, you can see this is what it looks like for one cycle, which is what I have graphed. It goes through the zeros 3 times, and then it goes up before it goes down. So the idea is that since it's periodic, you should be able to copy the pattern of what you see. So if you look at 0 pi, 1 pi, 2 pi, 3 pi, that's going to be a 0. Negative pi, that's 0. Negative 2 pi. So anything with an integer in front of it is a 0. After that, the patterns are a little bit hard to see. So if we just kind of copy the actual physical sort of up, down, this is on its way up. It has to go all the way up before it's allowed to start coming back down. If we head over here to the negative, it's on the way down. So it has to negative pi over 4, negative radical 2 over 2, negative 1, negative radical 2 over 2. Now it's on its way up, so now it's going back up. Now it's back down to 0, radical 2 over 2, negative 1. There's a definite pattern to this. And so here is the sine curve from negative 3 pi to 3 pi. And we graph it that many times so that we can really kind of investigate some patterns so that you can really see some positive and negative values. But again, notice that it's not pointy anywhere. It does continue on forever in both directions. So the period for this is one cycle of your circle, not the actual whole graph, but just one cycle. So what I have in the blue square, your absolute max, of course, and your absolute minimum. Now, the zeros. If we look closely at the zeros, just the places where it touches the x-axis, it touches the x-axis at integers. There's no fractions. So we're going to call this pi k. K is an integer. Be prepared to be able to follow a pattern. Find a pattern and explain the pattern so that it can be carried out to a negative infinity to infinity. Don't just say that the 0 is at 0. That's too specific. Now, the absolute max. The first one, if we're reading it from 0 to 2 pi, is at pi over 2. Now, in order to get to the next one, we have to go through the whole cycle, and then it goes to the next one. So that is 2 pi. So then we're going to say plus or minus 2 pi k. Again, where k is an integer. So it doesn't matter how many times we go around. If we start at pi over 2, if we add or subtract 2 pi, we will end up back at another maximum. Minimum, we have to start the first one. 3 pi over 2. And again, you can see the next low. It's harder to see because it's over here. That is 2 pi away, so plus or minus 2 pi k again, where k is an integer. You have to describe it for the entire graph, not just for one little section that you want to talk about. The amplitude for the whole graph, we had a formula for this, which we spent a whole day on last week. But the amplitude is from 0 up or 0 down, so the amplitude here is 1. The domain, of course, is all reals, or negative infinity to infinity. And the range goes from -1 to 1. Now for the cosine. Just to generate some values, the cosine also has a pattern, but it is a different pattern than sine. The cosine, when you're looking at the unit circle, the cosine comes first, right? Because it goes cosine, sine. Cosine goes with the x values, just to sort of get with what we're looking at here. So at pi over 4, it's radical 2 over 2, which we already know is 0.707. At pi over 2, it's 0. 3 pi over 4, negative radical 2 over 2. At pi, it's 0. 5 pi over 4, now we're down here, it's negative radical 2 over 2. 3 pi over 2, straight down, 0. 7 pi over 4, now we're coming back up, so it's positive, radical 2 over 2. And 2 pi, back to where we kind of started. I know 0 isn't on there, but that's a 1. So let's put 0 on here, and let's put the 1. So we have a graph. We have the ability to draw the whole graph, I should say. 0, 0 is not on this graph. So you have the values, you can see them, and you can plot them. We have the point 0, 1, so that's up 1. 0, 0 is not on this graph, so we don't put it on there. It's not on every graph. At pi over 2, we're back down to 0. 3 pi over 4, negative radical 2 over 2. At pi, we're at -1. I might have had positive 1 up here. Sorry. I was like, wait a minute, something's wrong. Sorry about that. This is really -1. You probably caught that, though. 3 pi over 4, negative radical 2 over 2. 3 pi over 2. Now we're on our way up, and at 2 pi it stops. So I'm just going to draw this in here. This is one cycle. So it looks different than sine. So that is one cycle. And I'm just taking a look at some patterns here. Pi over 2, 3 pi over 2. This thing we know is going to come back down because that's just how this works. And so we know that it's going to look like this. So it looks like anything with a 2 in the bottom, negative pi over 2, negative 3 pi over 2, negative 5 pi over 2, and so on, are all going to be at zeros. If you look at the maximum, this is at 0, 2 pi, and it'd probably also be, so it looks like it's evens. So at negative 2 pi, it's also going to be at the maximum. Your minimum is at pi and 3 pi. So your minimum is at odds. So negative pi, negative 3 pi. I know I didn't plot them all. I don't think you need to plot them all. You already know what the pattern looks like. So there is the entire cosine curve. So again, let's summarize this. Period is 2 pi. Absolute max is 1. Min is -1. The zeros are at pi over 2k, but k is an odd integer. Because if we divided by 2, like we did 4 over 2, it doesn't come out as a fraction. So we want to make sure it comes out as fractions. So 1, 3, 5, 7, and so on. Your maximums are at pi k, but k is even. And your minimum is also at pi k, but k is odd. And the rest of this matches the sine. Amplitude is 1, domain is all reals, and the range -1 to 1. So what exactly are we going to do with this? Let me show you. So when you go to do a graph of any trig function, be prepared to identify the amplitude and the period. This is the parent graph. We just did this. Amplitude is 1, period is 2 pi. Right now, we just know that because we just studied the parent graph. We're not really telling anything. We can't really tell from this. We'll go over that in the next couple weeks, days, I should say, as to how you can figure that out from the equation. So your amplitude is going to go on your y-axis. We're going to go up 1 and down 1. The period. You're going to make your 4 marks, and on the 4th mark, you're going to go, what is the period? Halfway, please also mark the halfway point. Now the sine. The pattern is this, and you have to have this memorized. It's a 0 at the beginning, middle, and end. That's where it's a 0. Beginning, middle, end. It goes up first. So the maximum is between the first 2 zeros, and the minimum is between the next 2 zeros. Connect the dots. That's it. Cosine, again, because of the parent graph, we know amplitude is 1, period is 2 pi. Amplitude, up and down, period, 1, 2, 3, 4, make your 4 marks. There's your 2 pi. Please also mark the halfway. Now cosine starts at the high, ends at the high. So it's at the max, at the beginning and end. It's at the minimum at the halfway spot. So halfway is pi, which is why I want you to label it, and halfway we're at the minimum. Now in between there, you know, we're at the fractions. You're on the 0, you're on the axis. Please do not connect this pointy. You have to have those patterns memorized. Otherwise, you will not be able to draw these graphs because you will not have a calculator. Now for this one, we're going to go back over the cosine. It says to graph this one and the cosine of x plus 2 on these same axes. Well, you already know what x plus 2 does. It moves it up 2. So the transformation is obviously up 2. So let's start with the parent graph. 1, 2, 3, 4, that's where 2 pi is going to go, pi. We're going to go up 1 and down 1. Cosine starts at the maximum, ends at the maximum, halfway it's at the minimum, then you have your zeros. Now to move this thing up 2, we are going to move the x-axis. Everything you do is from the x-axis. You count the amplitude from there, you put your zeros on there, so we're going to just give ourselves a dotted line up 2. And now we're going to be able to do everything from that spot. So it starts high, but high is up 1 from the x-axis. Ends high, that's also up 1 from the x-axis. Halfway it's low, which is down 1. Now your zeros aren't going to be zeros really, they're going to be on the dotted line. They're actually moved up 2. And so there is the graph moved up 2.